One of the main arguments used to deny the possibility of interstellar travel is the question of distance. The closest star, Alpha Centauri, is 4.2 light-years away. If astronauts traveled to this star at the speed they reach the moon, it would take them roughly 100,000 years.
Okay, make it smooth.
Another major obstacle in obtaining interstellar travel would be the amount of fuel required.
When you're driving a car, the amount of propellant you have to carry in your fuel tank is very small, just a few percent of the weight of the car. When you're trying to carry enough propellant to take a rocket ship vast distances, even in our solar system, pretty soon you find yourself carrying propellant just to propel the propellant. This problem skyrockets to infinity.
So we'd want to go to propulsive systems that have very, very high exhaust velocities. And with a chemical reaction, essentially a barely contained explosion in a chemical rocket, you have a limit to that. And that limit is currently almost met by the shuttle engines. You can't go beyond it very well. And so we have to go to some other kind of propulsive source.
Even if we could develop a radical form of propulsion capable of obtaining near light speed, Einstein's theory of relativity tells us that we would encounter another enormous problem.
There's a law of relativity that says that the closer you try to accelerate something like a rocket to the speed of light, the more massive it becomes. And so it becomes infinitely massive at the speed of light, which makes it impossible to get there.
New way of thinking about the universe.
Physics professor, Rhodes Scholar, and author of the national bestseller, The Elegant Universe, Dr. Brian Greene has been researching relativity and quantum physics for several decades. Dr. Greene brings up another problem with traveling near the speed of light.
If astronauts one day go to the moon and beyond in ships that travel at a substantial fraction of the speed of light, when they return to Earth, relativity really tells us they will be in for a shock. Because while they may have thought a few months went by, they'll get back to Earth and they'll see that years and years, hundreds, perhaps thousands of years will have gone by. This is not science fiction. This is science fact.
So the idea of traveling between solar systems in normal space, I don't believe is possible. We have to invoke jump gates from Babylon 5 or warp drives from Star Trek. And of course, in 100 years, who knows what might develop.
Although at present the solution to interstellar travel may sound like science fiction, a growing number of scientists are exploring radical new theories that may circumvent these obstacles.
We're beginning to discover in theoretical physics that maybe our entire universe is just a subset of a much greater universe, a multidimensional universe that's being investigated in modern superstring and M-brane theory. In the context of those theories, there may be new possibilities to, so to speak, step outside of space-time, move somewhere else, and come back into our universe at some distant location.
Einstein teaches us that the fabric of space can respond to its environment. It can warp and curve. And in fact, the equations of general relativity allow the fabric of space to have severe bends. So long as you distribute matter and energy in the appropriate way, you can bend space fairly significantly. So in principle, it's possible that if you want to go from one end of the universe to another, you don't have to travel all along the fabric of space. Maybe you can bend the fabric of space and then travel from here to here, very short journey by a shortcut, a wormhole.
Continuing research into the possibilities of interstellar travel are currently being conducted by NASA's Breakthrough Propulsion Team, headed by Mark Millis.
What we're trying to do is break it down into the smaller steps to attack the critical make-break issues of some of the things we need to find out. Can you propel a vehicle without propellant? Can you conserve momentum in the process? The issues of faster-than-light travel, the causality violations and things like that. Address those in smaller steps to see if you can eventually lead that way.
Today we have scientists working for NASA, working for the U.S. Air Force, working for British Aerospace, working for other firms and agencies that we don't even know about, that are intent on discovering how to do star travel. They have already decided it can be done, theoretically. Now the question is, okay, what's the trick? Let's figure it out.
if you look back 50, 100 years to what sciences we knew then and what we could do today, who knows what we could do in the future.
So I have an inherent optimism about progress, and I think that what seems impossible today will possibly be possible tomorrow.
We're at that point of imagining these things, asking these technological questions. Clearly, that opens the door to at least the possibility that others have figured it out already.
T-minus 15 seconds and counting. 9, 8, 7, 6, 5, 4, 3, 2.
All right, there it goes.
In 1965, Gordon Cooper was the last American astronaut to go up into space alone.
What they think on it. Now, the action that I have taken is to turn off my old 5G switch fuse and my...
He orbited the planet 22 times.
I think that those of you that know me know that I've always spoken honestly and straightforward to you. I intend to do so today.
10 years earlier, while stationed at Edwards Air Force Base, Cooper witnessed an event that has yet to be explained nearly 50 years later. He was supervising the filming of a precision landing facility for F-86 fighter jets. Suddenly, a saucer-like craft flew directly over the cameraman. 3 landing gear apparatus opened, and the object landed on the dry lake bed.
They took all saucer shape, double-ended shape, metallic, and they went out, picked their cameras, and moved on out toward him, filming. And he lifted off, put the gear back in the well, and climbed out at a very high rate of speed and disappeared.
Cooper had the film footage of the strange craft developed. By the time it returned from processing, he had gone up through the ranks to report the incident.
Finally, with the colonel telling me to, when the film arrived at my desk, to put it in the carrier pouch. There would be a courier there at my office by that time already, and they'd arranged for him to fly in our base airplane back to Washington with these films.
Did you watch the film?
We didn't have a chance to run it. I had a chance to hold it up to the window and look at it. It was certainly a good film.
After the developed film was sent by plane to Washington, it was never seen or heard of again.
Did you ever keep in touch with anybody about it or discuss it?
How would I keep in touch with anybody about it? There's no way within the military or within the government of keeping track of something that is classified unless you're directly involved in it, and I was not.
Will you be ready?
I went into space to learn about the universe we live in, to get new insights, to go beyond the boundaries of our known existence.
Apollo 14 astronaut and 6th man on the moon, Edgar Mitchell, states in his book, The Way of the Explorer, that he's never had first-hand experience with UFOs. However, he has met with credible professionals within 2 governments who have testified to their own first-hand experiences with close encounters during their official duties.
The only people I know of that claim to have been in that position are former intelligence, military, and government people, and some contractor people, whose official duties in the early days were to investigate this and know about it. Those people were under, at that time, great restrictions and high security clearance that prevented them from telling the general public about it.
What we photographed up there affected me for the rest of my life.
In 1964, former U.S. Air Force Lieutenant Bob Jacobs was in the 1369th Photo Squadron at Vandenberg Air Force Base in California. He was in charge of photo-optical instrumentation at a tracking site in Big Sur, 124 miles away. His mission was to film an Atlas rocket go through all 3 stages of powered flight. This particular mission was part of the Nike Zeus objective for the development of an anti-missile missile during the height of the Cold War. All cameras rolled as they heard liftoff from Vandenberg over their radio.
5, 4, 3, 2,